With this project, we have chosen hypothesis testing as our topic. What we wanted to do with this is we wanted to use real life scenarios based on our own personal majors and just go into depth about how hypothesis testing can be used in the real world. So these are some definitions and important terms that we need to start out with. Hypothesis testing is a method used to make inferences and draw conclusions about a population based on sample data. It involves using two hypotheses: a null hypothesis, which is the status quo, which is a default assumption where there is no significant difference or change between the population parameters. An alternate hypothesis is a hypothesis that infers change or a significant difference in the population parameters.
As an electrical engineering major, an example of how hypothesis testing can be used in my discipline would be by testing the insulation resistance of power lines. This is important because it's crucial that power lines are able to withstand high voltages without breaking down. And so they must meet a minimum required resistance level. An engineer would want to evaluate the data obtained through testing in order to determine if they meet proper quality and safety standards. Initially, they would declare a null hypothesis, like the leakage current of the power line is less than 1 milliamp, and an alternative hypothesis, like the leakage current of the power line is greater than 1 milliamp. Afterwards, they would conduct the experiment by testing 50 power lines of the same length by applying a high voltage and measuring the resultant leakage current. And then they would choose a statistical test like a t-test, as well as choose a significance level of 0.05 to determine the probability of rejecting the null hypothesis. The t-test would be used to compare mean values obtained from the measurements and also give us the p-value, which represents the probability of getting the mean insulation resistance under the null hypothesis. After analyzing the results, if the p-value is less than 0.05, we reject the null hypothesis, meaning the power lines are defective. And if the p-value is more than 0.05, then we fail to reject the null hypothesis, meaning the power lines are up to standard and they are safe.
For our third hypothetical scenario, we have our aerospace engineering. Suppose you're in the aerospace engineering field and you're in charge of finding the burn time of your company's solid motor. To properly categorize a rocket motor by its impulse, the product of its thrust time duration over its burn time, you must find the mean value of the burn time of your product. Burn time in motors is determined by the composition of the grain and the shape of the grain. The goal for this motor's burn time is 2 seconds. Using hypothesis testing and repeated trial statistics, firing the rocket motor, you can conclude the average burn time of the motor. The null hypothesis for this example is a burn time of 2 seconds. An alternative hypothesis is a burn time less than or equal to 2 seconds. Our sample size is 100 static fires. Because if it's 100 static fires, we use z-test statistics because it's for a larger group. And our alpha theoretically was 0.05. The z-test will give us a p-value that rejects or does not reject the null hypothesis. The conclusion gives us the burn time, and if we theoretically also know the thrust time, we can calculate the total impulse and categorize the solid motor into its proper motor class.
As many of you know, Florida has the highest number of hurricanes in the US, and many houses get destroyed or flooded. As someone who lives on the beach and has had their house flooded, I thought it was appropriate to create a hypothetical scenario of doing a hypothesis test on a structure that prevents water from getting into a house. In the engineering field, hypothesis testing plays a crucial role in validating assumptions, analyzing experimental results, and improving processes. For my scenario, an engineer will be testing a ramp-like structure that prevents water from getting into a house during a flood. The null hypothesis will be that the water gets past the ramp and gets into the house. The alternate hypothesis will be that the structure successfully stops water from getting in the house. How the experiment will go is the engineer will create an aluminum structure shaped like a ramp, as well as a silicone sealant. The ramp will raise from ground level to a 45 to 90 degree angle to stop the water. This structure will be tested against a garage, since that is usually where water gets in during a flood. The engineer will then fill up 5-gallon buckets of water and throw them against the structure and then record how much water, if any, gets into the garage. They will then repeat this 10 more times to improve accuracy. For this test, we will use a significance level. A significance level is the probability of rejecting a null hypothesis when it is actually true. In this case, we'll be using a 0.05 significance level. In other words, this indicates that there is a 5% chance of falsely rejecting the null hypothesis. We will then determine the p-value, which is the measurement that assumes the null hypothesis is correct. If the p-value is smaller than the significance level, the engineer will reject the null hypothesis and conclude that the structure will provide efficient flood preventing technology for homeowners. However, if the p-value is greater than the significance level, the engineer will fail to reject the null hypothesis and begin designing a better structure that will provide more efficient results.
Hello, my name is Eric Ginsberg, and I'm a mechanical engineering student here at UCF, graduating in the fall. My future career in the engineering world is going to be in theme parks and specifically ride design. So I decided to use hypothesis testing in a scenario similar to that of one I've seen in my internship experiences. In theme parks, the safety of guests is the most important thing when designing an attraction. Statistics can be used to determine if certain functions are up to a reliability standard to ensure the guest safety. One scenario this can be applied to is the launch on a roller coaster. In ride design, to ensure no vehicle crashes into another, there must be a point on the track where the vehicle can be stopped in between each ride vehicle. When there is a launch, it cannot be stopped on the launch, and this is usually followed by a large section of track with no brakes. In the image shown here, this is the world's tallest roller coaster, Kingda Ka. There is a long launch before it goes over the large 456-foot tall top hat. There are no brakes going up or down. The nearest brake is on that final hill that you see the ride vehicle going on. So it is in the best interest of an engineer to determine when you can safely launch another ride vehicle to ensure that it won't crash into the next one. A hypothetical scenario would involve a day's worth of dispatches, which could be upwards of over 1,000, but we're going to say 1,120 for this scenario. The null hypothesis can be stated that the time to clear this large section of track with no brakes takes less than or is equal to 30 seconds. The alternate hypothesis for this scenario would then be that clearing this zone would take longer than 30 seconds. So it'd take longer than 30 seconds to clear that top hat and that hill before it would hit the brakes. The data used for comparing these hypotheses would be the time it takes to dispatch the ride vehicle. This data would then be put through a z-test statistic due to its population size. The p-value calculated by this z-test statistic would then be compared to the p-value for a significance level of 0.0005. This is the most strict significance level possible, and it must be that strict as it is guest safety that is of the utmost importance to the engineer. While a less strict significance level could be used, again, guest safety is the most important in design, so it must be the most scrutinized. If this p-value of the data is less than the p-value of the significance level, then the null hypothesis is not rejected. However, if the p-value is greater, then we reject the null hypothesis, and the dispatch times for the attraction would need to be increased to ensure rider safety.
So this is my scenario. I am one of 3 mechanical engineers, and the scenario that I have chosen is the testing of a new propulsion system for a spacecraft at NASA. The background of this is a mechanical engineer working at NASA who is tasked to perform a test to see which propulsion system is more effective. The null hypothesis is that there's no significant change from the old system, and the alternate hypothesis is the new system is more efficient and has an increased thrust. So with this, the experiment that is conducted is the engineer selects a spacecraft with the old propulsion system and a spacecraft with the new propulsion system. Both subjects are set off with the same operating conditions and environments, and with that they collect data based on specific impulses, thrust output, and fuel consumption rate. with the hypothesis testing, a t-test is used in which they compare the two groups to determine which one to determine if they differ or if they come out to the same efficiency. So what a hypothesis test is basically, or your statistical test, which is used, which can be a z-test if there are multiple. I'm forgetting it. Let me start again here. Okay. So my scenario as a mechanical engineer is for testing a new propulsion system at NASA. The background of this is a mechanical engineer is working at NASA and is tasked to perform a test to see whether the new propulsion system is more effective. So here, the null hypothesis is that there's no significant change from the old system. And the alternate hypothesis is that the new system is more efficient and has an increased thrust. The test type here that is used is a t-test because there are only two groups that are being studied. So here the experiment is the engineer selects a spacecraft with the old propulsion system and a spacecraft with the new propulsion system, and both subjects are set off with the same operating systems and conditions. The data is based on specific impulse, thrust output, and fuel consumption rate. With the hypothesis testing, the engineer applies a t-test to compare the performance data from subject 1 and 2, and the p-values are calculated and determined and are compared to a significance level of 0.05. A t-test is employed to compare the means of two groups, and they determine whether the two groups differ or if a procedure or treatment affects the population of interest. A t-test is a statistical test which determines whether your null hypothesis should be rejected or not. In most cases, you base your judgment on the p-value provided by the statistical test, and your present level of significance for rejecting the null hypothesis will be 0.05 in most circumstances, such as in mine. What that states is there is a less than 5% likelihood that the data would be seen if the null hypothesis were true. So the p-value that was determined from this hypothesis test is 0.025. So with this test, we can conclude that since the p-value is smaller than the chosen significance level, which is 0.05, the engineer rejects the null hypothesis and concludes that the new propulsion system is more efficient and should be implemented in further experiments.